Bases. Hmm. Have you ever heard of caustic soda? Or have you seen someone use slaked lime to paint tree stems? Or have you ever wondered why some cleaning agents are able to remove fat and dirt? These materials are called bases. They are compounds, have better taste, a soapy texture, caustic, and causes burns and damage to tissues. An example of this is sodium hydroxide, or what's known as caustic soda. Its chemical formula is NaOH, which is a powerful chemical compound that is used in the manufacture of drain cleaners and soap. Either calcium hydroxide or what's known as hydrated lime, which is used to paint the stems of trees in order to protect them from insects. Also, an example of the bases is magnesium hydroxide, which is included in the manufacture of medicines that are used to treat excess acidity in the stomach. Many of the detergents used in our homes also contain bases, such as oven cleaners, because these substances produce hydroxide ions which react strongly with fats and remove dirt. Therefore, due to the importance of the bases and their multiple applications in our lives, scientists have been interested in studying them and learning about their properties and interactions. So let's get acquainted together with the qualities of bases. The first property is that base solutions are electrolytes. Bases are electrolytic substances that ionize when dissolved in water, and their ionization produces negative hydroxide ions and positive ions that vary depending on the base, which makes their solutions conductive to electric current. But what does that mean? Let's consider the following example. Sodium hydroxide and NaOH. As we see, when dissolved in water, it will ionize. That is, it will dissociate into positive sodium ions and negative hydroxide ions. This is what makes the sodium hydroxide solution an electrically conductive medium. Therefore, the bases are called electrolytic substances. That is, their solutions are conductive to electric current. The second property is the strength of the bases. Some bases are strong and some are weak, and it depends on the degree of ionization of the base in the water. Strong bases. If the base is strong, most of its molecules are ionized when dissolved in water. This leads to the formation of relatively large amount of hydroxide ions. Basic qualities are strongly pronounced. Also, the degree of conductivity of its solution to electric current increases. For example, sodium hydroxide, which is one of the strong bases, so most of its molecules will be ionized in water. Thus, the degree of conductivity of its solution to electric current is high. As we can see, when writing the ionization equations for strong bases, the arrow is written in one direction, and this indicates total ionization. While weak bases, if the base is weak, then a very small percentage of its molecules are ionized, and the bulk of the molecules remain without ionization. Therefore, only a small amount of hydroxide ions are produced in the water. The basic qualities are weakened, thus the conductivity of its solution to the electric current is weak. Such as ammonia, which is one of the weak bases. So, a small percentage of its molecules will be ionized in water, and therefore the degree of conductivity of its solution to electric current is weak. When writing the ionization equation of weak bases, it's written with two opposite arrows, which indicates partial ionization. Let's get acquainted with some strong and weak bases and their ionization equations in water. As we can see, some bases contain a hydroxide ion in their composition, but some of them do not contain it in their composition, like ammonia, but when it reacts with water, it produces a hydroxide ion. Also, some metal oxides have basic qualities in their aqueous solution, although the hydroxide ion does not include in their composition, such as sodium oxide, potassium oxide, and calcium oxide. These oxides react with water to produce negative hydroxide ions. For example, calcium oxide reacts with water to produce calcium hydroxide, which is one of the strong bases. So it will be completely ionized to positive calcium ions and negative hydroxide ions. So, aqueous solutions of some metal oxides are basic. But how can I distinguish basic solutions from others in a safe way? Especially since most of them weren't tasting it, because they are caustic and causes burns and damages to tissue. So let's figure out how to detect basic solutions together. For this, substances called indicators are used, which are substances that change their color depending on the type of solution they are in. They are natural indicators, and there are industrial indicators. We're going to use the same indicators that we used in the acid video, so let's see together how their color will change in basic solutions. Natural indicators include tea or red cabbage. When a base substance is added to the tea, as we notice, its color changes from red to black. While when using cabbage, let's observe the change. So we notice that its color has changed from purple to green or blue. You can try it at home to detect basic solutions. As for industrial indicators, such as litmus papers. Some of them are blue and some of them are red, but for the detection of base, we use red litmus papers. Notice how their color changes in the basic medium. As we can see, its color changes from red to blue. There are also chemical indicators such as methyl orange, which gives a yellow color in the basic medium. Big thanks for watching. At the end, don't forget to like, share, and subscribe to receive my new videos.